pi is exactly 3. Now that I have your attention, I want to say something. The approach in the video and lots of other things can be found in my short guide about the cross product in a much more general way. Basically, you can solve any linear equation system using only the cross product. You can solve homogeneous equation systems. Inhomogeneous systems, you can even invert a matrix by using the cross product. There is an English version and a German version available. Check out my Patreon for more details. And pi is not 3. It's 3.141 and so on. Okay, let's start with an easy task. We want to solve this linear equation system by using the cross product. I'm sure some people already know this approach. We just pick two linear independent rows of this matrix, for example the first row and the second row, and calculate the cross product of these two rows. So the first row 1, 0, 1, and the second row 2, 1, 1, and we want to calculate the cross product of these two rows. How do you calculate this cross product? For the first entry, you have to ignore this here and calculate 0 times 1 minus 1 times 1 is minus 1. So the first entry is minus 1. For the second entry, you have to ignore this here and calculate 2 times 1 minus 1 times 1 is 1. So the second entry is 1. And for the last entry, you have to ignore this here and calculate 1 times 1 is 1 minus 0 times 2 is 1. So the last entry is 1. So the cross product of these two vectors is minus 1, 1, and 1. By inserting this vector into the system, we can see that it is a solution of the system. So the rank of the matrix is 2, and the solutions x are multiples of this vector. So x equals s times minus 1, 1, 1, where s is a real number. And this is the solution of the system. If we inserted the cross product vector into the equation system and it was no solution, then the matrix would be of rank 3 and x equals 0 is the only solution. But in our example, this is not the case. The vector minus 1, 1, 1 solves the system, and therefore the matrix is of rank 2, and this is our solution. Let's take a look at another example. We do the same thing as in the first example. At first, we choose two linear independent rows of the matrix A. For example, this one and that one. Now we calculate the cross product of these two rows. So the first row 1, 1, minus 1, and the second row 1, 2, 3, and we want to calculate the cross product of these two rows. So for the first entry, we ignore this here and calculate 1 times 3 minus minus 1 times 2 is 5. For the second entry, we ignore this here and calculate 1 times minus 1 minus 1 times 3 is minus 4. Is minus 4. And for the last entry, we ignore this here and calculate 1 times 2 minus 1 times 1 is 1. Like in the last example, we have to insert this vector into AX. Inserting in the first two rows results to 0, but inserting in the last row we get 5 times 3 plus 2 times minus 4 plus 1 times 1, and this is equal to 2. 15 minus 8, 1, and this is equal to 8. And this is obviously non-zero. Therefore, A is of rank 3 and X equals 0 is the only solution to this system. Let's sum the approach for a 3 times 3 matrix up. The first step is to choose two linear independent rows of A. The second step is to calculate the cross product of the two rows. The last step is to insert the calculated vector in the system. Actually, you just have to insert in the row that was not involved in the cross product. If this results to 0, the calculated cross product vector generates the solution space. This was the case in the first example. If it yields something that is not 0, then x equals 0 is the only solution to the system. I hope this video was helpful. In the next video I will show you how you can solve larger systems, like this one, by only using the cross product.